Welcome back, everyone, and thank you for showing up for your learning. Here we are looking at solving systems of equations by graphing, and we're just going to be a document camera for this one, so we're just going to zoom in here, and then we're going to do a quick check with everyone in the room. If I'm zoomed in that much, is that okay? Can people see everything that's going on here?
Yes.
Yes, can you see in the back there? Riley, that's okay? Good, all right. Okay, so our first one, what we're doing when we're solving a series of linear equations is we're finding the point where the lines touch. That point where they touch is the single point that exists in the entire infinity of the xy plane. That's the only point that those two lines share. That point is called, therefore, a solution to each of the equations. It's therefore the solution to the system of equations. Now, when I'm graphing this, I'm thinking about my y equals mx plus b. Y is equal to m multiplied by x plus b. And I remember that m gives me my slope and b gives me my y-intercept. So I'm going to need a ruler here if I want to draw some really accurate sketches. Okay? If people want a ruler, I have some extras. Do I ever have some extras for you? Okay, so I'll put the extras up here if people need a ruler. All right, now let's carry on. So the first thing that I'm going to do when I'm graphing this line, y is equal to 2x minus 3. First thing I'm going to do is identify the b value here as minus 3, and I'm going to go ahead and plot that. That gives me my y-intercept, the place where that line is going to touch the y-axis. And then I am going to use the slope to go over 1 and up 2. Why did you go over 1 and up 2, Mr. Jennings? Someone answer this student's question. Why did I go over 2 and up 1 for this line here? Fisher.
Because when you have like a number, you always put it over 1.
Yeah, 2 is the same thing as 2 over 1. 2 whole pizzas. 2 pizzas, each pizza cut into 1 slice. Yes, so I am 41 divided by 1 years old is a fancy way of saying I'm 41. I'm no older or younger when I divide by 1. So this is the number 2 over 1, so that's my slope. So I go over 1 and up 1. And then I can put a line through that, and I can be careful to try and hit as many of those grid points as possible on the way through, because I also know that this would be a solution, that, and that, okay? So now I've shown that line going through the xy plane. That's an infinite number of points. And now I'm going to graph this one. I'll graph it in a different color. I'll use orange. First thing I do is I graph the b. So that's up here at plus 2. That's when x is equal to 0. Negative 3 times 0 is 0. So I have y is equal to 2. So that's the point x is 0, y is 2. And then I notice that this line, I have negative 3. So when I go over 1, what do? I need to go down 3. I run 1 and rise negative 3. So that there is my solution. I see it right away. I'm going to just remember that's it. I can also go backwards 1 and up 3. Would be another point on that line, or over 2 and down 6. So those are 4 of the points along that line. Join them, and together they will rule the universe as father and son. Only at the point negative 1, 1, negative 1. So the solution here, the solution is 1, negative 1. Get in the habit of writing down the solution as a point. Okay, you want to write the solution here as a point. You don't need to write it x equals 1, y equals 0. Just write it as a point. And remember that the point is alphabetical. xy is equal to 1, negative 1. That's the solution to the system of linear equations. That's how you do it. It's really that simple. Really that simple. Okay, you need to know how to use m. You need to know how to use b. You need to know how to graph a line from y equals mx plus b. If you want a review of that, let me know and I'll review it with you. Okay. If you don't need a review of that, then you're good. Okay. So let's do this one together. Number 2. All right. First thing I'm going to do is graph my b. So this one here for line A, I see that it's plus 1. So I'm going to go put in that at plus 1. And now instead of going over 1 and down 5/3, I use a trick here when I have a fractional m. So this m is equal to negative 5 over 3. I want to remember that slope is always rise over run. Okay, so when this line runs 3, it rises negative 5. So I'm going to run 1, 2, 3, and rise -5. 1, 2, 3, 4, 5. Okay, there's a point on the line. All right? And I can put another point in over here. 1, 2, 3, 1, 2, 3, 4, 5. Point up there. All right? Cool. Cool, cool, cool. Draw my line. I kind of missed, but you get the idea. Use a ruler, make sure it's accurate. All right, yeah. Now, let's take a look at the next line. I have -1/3 x minus 3. So I'm going to go ahead and graph the -3. And then this is my rise over run. So when I run 3, I rise -1. When I run 1, 2, 3, I rise -1. Aha! There it is. There is the point where the two lines are unified. But notice I could have written this. So this one for the m is equal to -1/3. But that is the same thing as saying m is equal to 1 over -3. They are the same. The negative is just floated to the top, but it is the same. Why? Because I can run -3, 1, 2, 3, and rise 1. That gives me that point. Notice that's still on a line with all of these points. So it doesn't matter which direction I go so long as my signs are correct. So there we go. There's my solution. So then I have xy is equal to, and I need to find this point. This is the point 1, 2, 3. So that's the point. X is 3 and y is -4. 3, -4. That one is done. All right. So these ones, so this caused some problems in the homework. If I have a line, the only tricky thing here is the line x is equal to 3. What's tricky about x is equal to 3, that line? Alex?
It's just straight.
Yeah, straight. Here's the point x is equal to 3, right? But there's also x is equal to 3 here. And there's x is equal to 3 there. There's no y. So it's just all the possible y values for when x is equal to 3. It's this line. It's a vertical line. X is equal to, that gives you a vertical line. And it's just at that point, okay? And then the line y is equal to -x plus 1. So it has this here, and then it's a -x, so it goes down here. I see that this is my intersection, okay? You can go ahead and do that one on your own, but I promise you, you're going to find the line goes through here. Boom. Intersects right there, okay? How did I know that? I look at my B first, I graphed it, and then I look at my M. My M is -1. -x, that's -1. So -1 could be written that way if you really want. -1 over 1. So I run 1 and I rise -1, that point. I run 1 and rise -1, that point. I run 1 and rise -1, that point. Yes, go ahead. So that is how I solve these things graphically. Now, I've been telling you over and over, you want to start visualizing the lines. Graphing the lines in Desmos is just typing. So you can type in Desmos and it shows you what the line looks like. Then you want to look at a line in y equals mx plus b. Imagine the b. How high up the y-axis does it touch? And then imagine the m. How slopey is it? And then imagine that picture, and then keep that picture in your mind, see another line, and then imagine where did they touch. And when you can start doing that, and then you check your work in Desmos, your brain's going to become superpowered. Okay, it's really going to add to your learning. So before I graph these ones, I'm going to visualize these lines, and I'll talk to you about what I see. I see a line that touches the y-axis a little bit high up here. Well, it's above 0. It's at 1, and it's very slopey. It's going to rise very quickly. And then I see a line that touches below 0, and it's not very slopey. I know that the intersection is going to be around here. And in fact, I can tell you exactly where it's going to be. It's going to be right here, right at that point. -3, -1. Point -3, -1. And I just get that from visualizing. Not doing the algebra in my head. I can also do the algebra in my head. But I can do that in my head because I've practiced visualizing over and over. It's very fast. Now, the only other thing that's going to be tricky in here is when you get to some that need to be converted. So go ahead and turn to this is page 3. All right, you'll see question number 12. I'm going to do question number 12 with you because I quite like the number 12. And then I'm going to release you to do this work on your own. That way I can talk to you one-on-one. Now, when I'm doing this, I cannot effectively visualize that. I'm not able to. I also don't really like graphing it. I can throw it into Desmos and graph it and find the intersection, but that's just typing. What I can do to visualize this is convert to y equals mx plus b. So I need to just do that work to convert to y equals mx plus b. So here, let me do the work. I'm going to copy my first equation, x minus 4y. We're on question 12, Alex, equals negative 4. My first step is to move the x to the other side. So I am going to add x to both sides of the equation. All right. And then I get negative 4y is equal to x minus 4. See, I just wrote the x first because that's just my convention. X plus negative 4. Right, that's what I have here. And now I see I'm multiplying by negative 4y. So I'm going to divide both sides of the equation by negative 4. Okay? Now I get this equation as y is equal to 1 over negative 1 over 4x plus 1. Why is that plus 1? Because I have negative 4 divided by negative 4. So the two negatives cancel out. It's another version of anything divided by itself is 1. Okay? So that's my first line. I can now visualize that. I'm visualizing a line that touches the y-axis up at the point 0, 1, and it's falling slowly. It will touch the x-axis at the point 4, 0. Go ahead, sorry.
I was just wondering where you got the negative 1 over 4 from, but was that just the x?
Negative 1 over 4? Yeah, that's x over negative 4.
Okay.
Instead of writing it as x over negative 4, I decided to remove the x so that I can see my fraction more clearly. Okay. See, x over negative 4 is negative 1 over 4x.
What, 4x, why not negative 4?
Because I moved the negative to the top.
It wasn't the negative always at the top?
No, I just had positive x over there divided by negative 4. So something that I did that's causing some confusion, I'll show you what I did. I'll isolate it. It looked like this, x divided by negative 4. And then when I rewrote that, I wrote that as negative 1 over 4x. It's the same thing. Okay? And I want people to take a look at this and see why it's the same thing. Okay, this is 1x divided by negative 4. It's the same thing as negative 1 divided by 4 multiplied by x. Same thing. Okay? All this x did was migrate over there so that I could show you m very cleanly. I just wanted to show you m as clearly as possible. And then when I graph it, I run 4 and rise negative 1. There's my run 4 and rise negative 1. So I get this line here. And I could also run negative 4 and rise 1. So it gives me that line. And now let's put the line through it. Is that someone's ringtone?
Yeah.
Cool. Okay. Now I'm going to quickly convert this one. I could also use this formula back here behind me to convert it, but that's what I use for doing it in my head, not for just showing you. 5x minus 4y is equal to 12. So I'm going to do this on a big piece of paper so that you can see clearly. 5x minus 4y equals 12. Just make sure you copy down the question right. I did. Good. So my first step, subtract 5x from both sides. I'm not subtracting 5. I'm subtracting 5x. That is different. Now I rewrite. Negative 4y is equal to negative 5x plus 12. Just rewriting this plus 12 and this minus 5x in a new order so that it matches y equals mx plus b. Now I divide both sides by this coefficient, minus 4, and I divide both sides by that. So let's divide by minus 4 too. I have to do that both sides. Now I have minus 4 divided by minus 4 is 1. So I have 1y. Goal achieved. That was what I wanted, was y equals some number. Negative 5 divided by negative 4 is 5 over 4x. 12 over negative 4, that's negative 3. Done. That is y equals mx plus b form. Okay. So now I can visualize that and I can graph it. The thing I'm thinking about when I'm visualizing it is that this is bigger than 1, but barely bigger than 1. Okay? So what I'm imagining in my head, and you want to imagine this too. First thing is imagine it touching down here at minus 3. Second thing, imagine it being a little bit more slopey than 1. A little bit rising faster. You want to visualize that. If you remember, the other line did this. So I can predict that it's going to touch in the first quadrant. I can just see that in my head when I visualize the two lines. So I go down here to minus 3. I put in my dot. And then I just going to rewrite the line here. Y is equal to 5 over 4 multiplied by x minus 3. So there's my minus 3. That's my y-intercept. I get that from B. And then 5 over 4 means I run 4 and rise 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. There. Now I can put a line through those points. And then this is my system of equations there. And that is meeting at some non-integer point. That's hard to find from a graph. That you would want to use algebra to find the exact point of intersection. Okay? But you can tell just from looking at it, it's meeting at a point that's x is bigger than 2 and smaller than 3. It really looks like 2.5. So I'm going to put in a guess here, 2.5 or 2.5 for x. And then my y, well, it really looks like it's gone down more than a half. So this is less than 1/2. I'm going to say it looks like maybe a third, 0.333 in the y. And then I'm going to put a question mark there because I'm not sure. And then I'm going to go ahead and put it in decimals. Maybe we find something totally different because I made an error because I'm talking and doing math at the same time. Okay? But those are all of the tricky situations that you're going to find. And now you have all the tools to do the rest of the handout. So go ahead and try those. I had x minus 4y. Notice that I'm graphing the original equations that I was given. It was minus 4. Oh, so I did. I had a mistake there. X minus 4y. Where did I get my mistake? I need to subtract x from both sides. I need to subtract x from both sides. Here, I found my mistake already. My mistake is this has a positive slope. It's going to meet at this point right here. Okay, let's take a look. Why? Why did I make a mistake? I made my mistake right here. I added x to both sides. I made a very common error. I have x. I need to subtract x from both sides. That will flip the sign here. That will flip the sign here. That will flip my growth. It will cross here. There we go. People are rejoicing because I have made a mistake and you have not. There you go. So that is my intersection point. Great. And so see how I check my work? And then I get to have a woohoo moment as I fix my mistake. It's exciting to check your work and find your mistakes. So, because you're going to make mistakes. I'm not going to make a mistake on a test, believe me. If it's for marks, I'm not going to make a mistake. I do try and not make mistakes in front of you, but sometimes I do. And here's one of them. So that's my line. There's going to be the point of intersection right there. The other line, I did my conversion correctly. It was 5x minus 4y equals 12. There it is right there. And see, just like our sketch, it wants to intersect right there. Okay. My line was coming down to there. It had, this is what I did. I graphed this line. See? And then we got this one here, which is, oh, I had it almost right. I had 2.5 is actually 2.6 and 0.33. Yeah. Okay, so that's how you convert these lines to y equals mx plus b to graph them to find the solution. That's how it's done. All right, so that's it, everyone, for that topic.